Hello, my name is Juliet and I will be taking you through today's lesson. Our topic for today is our introduction to electricity. And before we delve into understanding the world of electricity, we need to understand the basics of voltage, current, which is intensity, and resistance. Electricity. We need to understand some terms and short explanations. Example, two poles component. These are electrical devices or components or elements with two poles, two pins or two plugs, which either produce or consume electricity. Example, the battery that we use in cars, or bulbs with two poles, or a DC motor. Generator. It provides electricity by chemical, heating and water flow power transformation. Example, battery, solar electrical plant, alternator, a storage dam. Receiver. It consumes electricity by changing electricity in heat, light and movement. Example, a bulb, a DC motor, a TV set, a fridge.
Tools for experiments: batteries, motor, fuse, insulated screwdrivers, connectors, insulated wires, bulb, resistors, switch or breaker, and multimeter.
Knowing what we need in conducting electricity, let's try to represent a circuit.
Now draw a square called a loop. List all symbols required, that is battery, bulb, motor, and breaker. Now erase areas to insert symbols. Then insert them in the loop, which is in the blank spaces.
Using our drawing that's on paper, let's put this into action.
We start by connecting the negative wire to the negative terminal on the battery. And then we connect this negative wire to the motor, one end of the motor. And on the other end of the motor, we connect the switch or the breaker. We connect this using the connectors. After connecting this switch to the motor, we connect the other end of this switch to one end of the bulb. Now we connect the other end of the bulb to the positive wire. And then the positive wire to the positive terminal on the battery. And at the end, this is what we get.
Now we move on to another term known as the conductor. And conductor is a substance or body that makes a circuit close or that closes a circuit. Examples are copper, aluminium, graphite. Then we move on to insulator. Insulator does the opposite of a conductor. It makes a circuit open, or it opens a circuit. Unlike conductor, an insulator opens the circuit. Now it's time for us to perform another experiment, and our goal is to build a circuit from a blueprint using tools and components. Now with this experiment, we are going to need a screwdriver, a breaker, our cables, our connectors to connect to the cables, our resistors, and our bulb, and finally our battery. Our battery is right here. Let's perform this experiment. Electrical current. This is similar to a flow of water going out from a water tank or a waterfall. Intensity. It corresponds to the quantity and the speed of the electrical flow at any point of an electrical circuit. Intensity. The tool used to measure the intensity is called ammeter. And when we come to this ammeter, there are two types. There is the multimeter and the analogic ammeter. Important notice, red cable in 10 amp hole
and then the black in the COM hole. And the symbol for ammeter is an A. Measuring circuit scheme. Note, measuring intensity is performed inside the circuit. Here are the tools or equipment that we'll be needing for our experiment. We have the battery, then we have our motor, our switch, our screwdriver, our connectors, our two cables, the negative and the positive cables, and then our multimeter. Now let's begin our experiment. Let's start with the negative wire to the negative terminal. Then we connect the other end of the negative wire to one end of the motor. Now we connect one end of the switch to the other end of the motor. Then we connect the negative cable of the multimeter to the switch. Now connect the red cable, which is the positive cable of the multimeter, to the positive wire and then we connect the positive wire to the positive terminal. Direction of electrical current, DC. When the motor is connected to the positive terminal, lamp is lit and motor runs from the right to the left. When the motor is connected to the negative terminal, lamp is lit, motor runs from the left to the right. Direction of a current is from red plug to blue plug. This type of current is called direct current, DC. As always, we start with the negative terminal. We connect the negative wire to the negative terminal. Then we connect the other end of the negative wire to the motor. Next, we connect one end of the bulb to the other end of the switch. And then we connect the other end of the bulb to one end of the positive wire. Now check all the joints or the connections to be sure everywhere is connected properly. As you can see, there's a break in the connection. Let's try to fix that. Now let's switch it on, and this is what we get. Now let's do the reverse, where we change the position of the bulb and the motor. Short circuit current. Connecting the two plugs of a single two-pole device by a wire is termed putting the two-pole element in short circuit status. Be aware that doing so with the battery may damage the two-pole element due to the high value of current. Note, if the two poles of the battery are connected together with a single wire, there will be an explosion of the battery. Now let's measure intensity in a circuit in series mode, where current is the same everywhere in the circuit. Now, when we come to safety, always remember safety first. Electricity can be dangerous. Electric shock occurs upon contact of a body part with any source of electricity that causes a sufficient current through the skin, muscles, or hair. A person can feel at least 5 milliamps DC. A current of 500 milliamps DC can cause fibrillation, which leads to cardiac arrest. However, the seriousness of the shock depends on paths that current takes through the body. Damage due to current is through tissue heating. Now we move on to voltage, and the measuring tool is voltmeter. There are two types of voltmeter, which are multimeter and analogic voltmeter. Important notice: red cable in hole marked V and black cable in hole marked COM. Note that measuring voltage is performed outside the circuit between plugs of a two-pole device. Short circuit voltage. Connecting the two plugs of a single two-poles device by a wire makes voltage drop to 0 volt. Another safety tip: voltage levels of 500 volt to 1000 volts tends to cause internal burns due to large energy available for the source generator in most cases. To avoid serious injury due to working with electricity, electrical devices, tools, boxes, wire equipment, always wear the appropriate safety gear. These include insulated tools, safety glasses, rubber-soled shoes, gloves, and dust masks called individual protection equipment.
Relation between intensity and voltage. Ohm's law, discovered by a German scientist, George Simon Ohm, from 1789 to 1854. For DC circuits, voltage, which is U or V, is equal to resistance times intensity. R is called resistance. Note, resistance is a voltage divided by an intensity. Another safety tip: internal burns are proportional to the duration of exposure multiplied by the square of the voltage divided by the resistance of the body. The resistance of human skin varies from person to person and fluctuates between different times of day, may be as high as 100,000 ohms. White or broken skin may drop the body's resistance to 1,000 ohms. Adding that high voltage electrical energy quickly breaks down human skin, reducing the body's resistance to 500 ohms. To avoid serious injury due to working with electricity, electrical devices, tools, boxes, wire, equipment, always wear the appropriate safety gear. These include insulated tools, safety glasses, rubber-soled shoes, gloves, and dust masks.
In our next experiment, we will make this installation and test an OK fuse and an out of order fuse using this illustration.